This is quite an office. I've never been a place like this.
No less, right? Is this true?
I could. I'm only filming in 1080p single camera right now. But what are all these things?
Yeah, so we are standing inside a kind of typical G-Speak rig. This is the kind of R&D system that we spent our first few years as a company selling to and working with our early adopter customers and partners, folks like Boeing and Saudi Aramco and GE, to develop custom applications on and in and other prepositions.
And who are you?
About right now. Who indeed am I? My name is John Underkoffler. I'm the co-founder and chief scientist of Oblong.
And what is Oblong?
Yes, well, Oblong is a company dedicated to the idea that the next big change, the next giant quantum leap, change in computing can and must and will come through a change in UI, a radically new user interface that's incredibly more capable and fluid and dexterous than what we have available today.
Beyond what we have with the Microsoft Kinect or something like that, or?
Yeah, the Kinect is an astonishing bit of engineering and value engineering and so forth, but it is very clearly intended for gaming. And for us, the threshold is real work, right? So can you be productive? Can you do all the things that you want to do with a computer with this new kind of interface that we're keenly interested in offering to the world?
And so you're wearing weird gloves?
In this case today, I am wearing gloves. We'll see some stuff that does not involve gloves and still uses gesture and hands. We'll see some other systems that use a spatial wand that's tracked in 3 dimensions and through 6 degrees of freedom to accomplish much the same thing. Because a big part of our story is actually a convergence story, the idea that multiple people using multiple devices, multiple input paradigms can all work together.
Now, tell me about these devices. What are these things?
It's perhaps not the most interesting part of our story, but in this system, those are high-fidelity motion capture cameras. They are, in particular, looking for the markers on the tags on these gloves. Each tag has a unique constellation of retroreflective markers.
Okay.
Each constellation...
What does retroreflective mean?
This is 3M Scotchlite. So this is the same stuff on your sneakers and on the road, so that you can see, glare from your own high beams.
Okay.
The cameras see only these markers, and each tag has a unique constellation which allows the fingers and body of the hand to be recovered in 3 space to an incredibly high precision, better than a millimeter in X, Y, and Z, which
cool.
is great.
Me standing here won't interfere? Okay.
That means that standing 10, 12, 16 feet back from the screen, we can be pixel accurate when pointing.
That is cool. Now, how much did this room cost to build? Because these things are not cheap. They don't look cheap, at least.
You know what? We have these lying around all over the place at our main lab in LA, so we just shipped one of those up here. Yeah, but let me dive into the.
But this is a multi-$100,000 room, probably that we're playing with right now.
Yeah, these rooms are intended for kind of high-value big data problems that, again, customers like Boeing are interested in using because it solves problems that can't be solved any other way, both from a UI point of view and some of the underlying plumbing type layers that we provide as well.
Okay, so what are we going to see here?
Well, what we're going to see in one sense is Minority Report made flesh, if you will. So part of Oblong's story is a little bit unusual in that even though it is in many ways a very traditional tech startup, it also passes through the film Minority Report. So those of us who were early on at the company had met as graduate students at the MIT Media Lab where we were working on a bunch of convergent threads. My own penchant, my own passion was for really, really new UI that would let people do stuff they couldn't do before. And that work actually led to a direct engagement with the film Minority Report. I served as the science and technology advisor for the film. I was responsible for the continuity and the realism of all of the future tech that appeared in that 2002 Spielberg film. But mainly, of course, I spent a lot of time working on the gestural interface, which itself grew out of real-world prototype-style work that I'd been doing at MIT. And coming out the other end of the film, I think it was clear to us, those of us who founded Oblong, that it was time to go back, be engineers, and build this stuff for real in a commercial context. So we really are building, among many other things, the Minority Report interface and all of the really interesting kind of CS-ish substrate that must underlie such a new kind of interface. So right away you see that that it's an intensely embodied interface. There's almost no latency or lag. The ideas of pushing and pulling and pointing and prodding and poking and all those other P words that we, as human beings interacting with the physical world, are expert at and give us our interface to the physical world, all of that stuff now works here in the digital world as well.
What kind of computers are running the system behind the scenes?
Well, that's actually a really fun part of the story. It's completely commodity hardware. This is a 4 or 8 core, white box bit of hardware.
Okay.
Running Linux in this case. Our stuff is a kind of meta OS that sits atop other OSs like OS X or Linux or Windows and binds them all together.
Cool.
So let's jump right in. As I vaguely alluded to just a few minutes ago, pointing is for us a really important idea. So pointing is something that's built into us as human beings.
Yep.
It's a gesture that's about geometry, it's about the room, it's about real world space. You do it to connect your body to distant objects, distant bits of space, and you do it for the benefit of other people who can apparently do magic vector math in their heads and know what you're pointing at. That's 100 million years of evolution right there. We decided to extend that as a sort of necessity into the digital realm. So, of course, it's always been the case that as a human, if you can see something, you can also point to it. Now we extend that to say if you can point to it, you can manipulate it. So this is a tremendously powerful and really fun kind of
and
action.
what did you do on your hands to make that action happen?
Yeah,
you just squeezed a finger?
That's right. G-Speak is a pose-based system. When you point with one finger like this, you get a cursor on the screen. And of course, you get one of those for each of the hands that you have. 1, 2, or 3, depending on the kind of human you are. And when you bring your thumb down gently like that, you've grabbed the letter.
Wow.
You've grabbed the element on the screen.
Okay.
So it's actually a surprisingly restful and low energy kind of work. There's a tendency, of course, for people to do this when they first start, but after about 90 seconds you relax into it, you can kind of shoot from the hip. It's the opposite of RSI inducing. You're not crunching your mighty frame in front of a keyboard that was never meant for human skeletons and human anatomies. You're free to move around and literally move around, right? So this is a spatial interface. It's tracking us throughout the room, and it knows where the pixels are in the room. So this is one of the basic premises of all our work. Real-world pixels, we sometimes call it. The idea that these pixels are not abstractions. They are actual structures that are present with us in the room. And they occupy, in fact, the same coordinate system that we do. So as soon as we say that this pixel is not at some integer x and y coordinate, it's actually at a floating point x, y, z triplet of coordinates measured from here. This is the origin in this room.
Yep.
And I'm measured from the origin in this room, and so are you. Then it's a very simple matter computationally, programmatically, and cognitively for us to enable pointing. It's a line that goes from this to that.
How long does it take to learn the gestures to make this new UI work? Because I've spent 20 years learning how to make my Macintosh and now my iPad work. How long does it take to relearn and learn to use your fingers?
I think because, you and I are, a bit older. We're in our late 20s now. But for people who are younger than that...
Not quite an exaggeration.
For people younger than that, you've grown up using the mouse, and so you don't think how fundamentally arbitrary it is. It is a kind of arbitrary construct.
Yep.
Our great advantage here is that everyone knows how to point already. So most people pick this up in seconds or a couple of minutes. You say, point. Everyone knows how to do that, and you grab it, and everyone knows how to do that. So, the advantage we have is that we're recapitulating stuff that people already know and giving it meaning in the computational realm.
Cool.
So we take that idea of direct spatial manipulation, where we're pointing as if with laser pointers attached to our fingers, and manipulating, the world at a remove, at a slight distance. And we add to that a small vocabulary of instantaneous gestures. So if we want to clean up our workspace, we can do that. Sort of hitchhiking, take me out of here.
Yep.
Pushing, as I suggested before, is an important idea. So pushing should mean the same thing here digitally that it means physically. You just push a bunch of stuff around.
Yep.
Clean up, make a mess like this. If we want to circle things up, we can just do that by making circles with our fingers. And again, what we're really saying is that we are inheriting, whether we like it or not, and I like it, a world increasingly filled with pixels. We've got big displays that are emissive, we've got bigger displays that are projected, we carry around portable devices with us that have, increasingly high resolution, agglutinations of pixels. All of this stuff there's no kind of lingua franca. There's no coordination among those pixels until now. So this system, by virtue of saying that those pixels exist in real space, provides a uniform way of addressing them.
Yep.
And the idea that geometry is built at the lowest level into this new kind of OS means that you can turn the corner. You can bring elements off of.
I didn't even know there was a projector on this. This is a rear.
In this case, it's just an LCD mounted horizontally. So that's something that makes total sense to us as humans, and it's something that's never really made computational sense before, because OSs to date have assumed that there's one display or there's two coplanar displays or so forth.
How smart is this system? If I moved this table and moved it over here, would it understand that it moved in relationship to the other screens?
Yes, so we'll show you a video in which exactly that is happening. Now, of course, there's nuances as to what the metaphor is supposed to be. Are these coffee cups sitting on the table? If so, as you drag the table around, they should stay where they are on the table. Or are they little magic flying carpets? If that's the case, then they should stay fixed in space as you pull the table around. And we'll show you video demos of both of those modalities.
Do you talk with Andy Wilson up in Microsoft Research?
Yeah, I went to school with Andy.
Oh, okay.
Back at MIT.
Well, he has a room similar to this where he sprays pixels onto you, so I could grab your name badge and put it in my pocket, or I could do things with data that's actually being sprayed on you. Are you playing with that kind of concept as well?
Yeah, so I'll show you a little of this. The idea of spraying pixels is something I've been working on since the early and mid-90s. So this is actually the work that the Minority Report production design team saw at MIT when they visited our lab. So this was a system called the Luminous Room.
Come on up here.
Sure. Yeah. And what we're seeing here is that we've broken open the CRT in those days, of course, and we've let the pixels go everywhere in the room. But we only put pixels where you actually want information. So in this case, we're detecting the location of this vase and allowing these digital artifacts to be loosely coupled to it. And with a gesture like that, rotational gesture, you can pull all that stuff inside the vase. And the same stuff has to come out, irrespective of where you move it in the room. Again, we called this system the Luminous Room, the idea that input and output would be co-located for the first time, and that we'd get rid of the rectilinear borders and scroll bars and all the appurtenances of a mouse-driven overlapping window system, and you'd just have information where you need it. So in this case, the room detected the presence of a chessboard and inferred what you might mean. We built a bunch of engineering-style applications, notionally CAD-like work, but distinctly without a CAD-style interface. In fact, you could arguably say that this system has no interface. It has your hands, and it has these physical objects, models of, in this case, beam splitters and lasers and mirrors and so forth. And so as an optical engineer, you simply move those about the workspace as you would in a real optics lab, and the system projects down the beam path for you and can add additional information like beam length and angles and all.
Now, I noticed you're actually controlling the video with your glove as we're talking.
I am, yeah. And
that comes pretty natural to you.
Second nature after just a few minutes, right? That means play, that means pause, and so forth. We'll see more of that in a minute. This is the same kind of idea. We've got a digital wind tunnel, as it were. We've got digital fluid flowing from right to left. That's not new. The mathematics aren't new, but what is new is this invitation to implicate a piece of the real world directly in the simulation. So we've essentially dissolved altogether the membrane, the formerly thick membrane between the digital and the physical world. So again, the system invites you to use your most expressive, dexterous, manipulators of meaning, which is to say your human hands, to form the world, to ask questions about the world geometrically, and have the digital part respond accordingly. And it's just a tremendously intuitive and powerful way to work. And we built this more sophisticated system for urban planners. And the proposition here is that they actually get to use, once again, the 3D models that didn't make sense after we started asking architects and urban planners to use CAD. Here, use the 3D models, we're saying, and in fact, we'll make the machine do the hard work of finding them in space, finding them on the table, and projecting down artifacts like the shadows.
These
are digital shadows. It is crazy. This is an inverse clock, so you get a bunch of tools that let you adjust the simulation, adjust the world. There's a simulated roadway. We can ask questions about what happens if you build a shiny building. Small adjustments in angle when you've got a shiny building makes a big difference as to glare. Are you blinding motorists on the road as you go by. And all of those questions have to be answered, and have to be answered very carefully when you work as an urban planner. So putting all of those questions in a context, again, where a 5-year-old, inarguably without any training in urban planning, can still operate the system, because every 5-year-old knows that to move a building, you reach out your hand and move a building.
And I bet, hooking up to big databases from like Waze or other systems that study traffic flow, you could see the actual traffic around this building and do all sorts of crazy stuff.
Right, so the point here is the front end. The front end invites all kinds of plugins from powerful back-end simulations and so forth. But again, our contention is we've got to take that first big step since the Macintosh toward giving giving human beings a front end, a UI that is befitting us, that's as expressive as we need to be, to communicate with machines that are now really, really good. We're still trying to squeeze all of our intent through that tiny, thin little pipe, the mouse and the keyboard, and a couple of other, input devices. But the machine's up here, and we're up here, so we need a high bandwidth pipe. And
it's interesting. I interviewed Doug Engelbart, the guy who invented the mouse, and he showed me some gloves that he had built. So he was thinking about glove-based computing, and it never arrived. Partly because he's, to do this kind of work, you take some money to buy all these sensors. But it's coming down in price, right? The Connect shows that new stuff arrives and comes down to a couple $100. And
Absolutely.
Changes what you can do.
That part's inevitable. We're trying to push it even faster than the inevitable Moore's Law approach. And, what Engelbart achieved in 62 and 65 and 66 is still not fully appreciated, I think. And he did all that without the benefit of another 45 years of tech development. So our hat is always off to him.
Yep. So what else do we got here?
Yeah, well, let's go back to modern day. This is the mid-90s. Then we get Minority Report, and now we get G-Speak. So with a different pose, with our hands held like a freshman physics XYZ coordinate system, you get to fly. And it's a simple and intuitive matter of moving left to move left, moving right to move right, up and down, and in and out gives you zoom control. So
a surgeon could use this to fly through the brain while he's operating on you, or fly through the heart, or check out what's coming off the CAT scan or whatnot.
Absolutely. So a big part of our work is about navigation of 2D pictorial spaces, navigation of 3D spaces, abstract data spaces, or incredibly importantly, real 3D spaces.
Now, what popped up right there? These
MR.
lines popped up. What are those?
Yeah, so those are indications that there is spatial annotation. So an analyst came along before us and marked certain parts of the world, and so those are spaces that we can fly to, and it's a kind of attentional interface. Just by getting close, you can learn about what someone else thought about that bit of the world. Or maybe it was the result of an automatic GIS system merge, or who knows what. And we can do that same thing ourselves.
Yeah.
So flying with one hand, using the other hand as a pointer at first, and then as a manipulatory instrument. So I can just click on that building, which happens to be City Hall in Los Angeles, and tag it as well. So now we've put some persistent data in the space, and it'll remain there for the next visitors, the next analysts to find. And this kind of flying is just really kind of deliciously easy and intuitive. It makes sense. It has a cinematic feel. It's very finely tuned to make the best possible use of the inertia of your body, all the proprioceptive intuition that a lot of evolution is built into your brain.
Yep.
So part of what we're doing is joining together the ways that computers have for the last 15 years done a great job of treating the human visual system, the visual cortex, and another piece of mostly ignored brain, which is all the stuff to do with your body. Your body wisdom, proprioception, haptics, the way that your brain understands your body in relation to space and movement through it. So when you bring those things together, it's an unbelievable new opportunity for insight and understanding.
So the code that you've written that's running the computers, they're watching. What's that code doing? Explain a little bit, because I know what a mouse move is on Windows. And I could watch as I moved my mouse around, and I saw what the computer could do or what the code could do. But what are the inputs or the APIs that you're watching?
Yeah, so that's a good question. Again, G-Speak as a kind of meta OS accepts input from kind of any and all input devices and input modalities. In this case, it's watching for gloves, and the input pipeline takes the location and orientation of each of the fingers and the back of hand tag there, and resolves that into a high fidelity position vector, position and orientation, and a kind of harshly quantized, low resolution finger pose readout. And in fact, if you look, let's look on the left there. I'll point to it with one hand and use the other hand to indicate what's going on. So this is an 8-character ASCII representation of my left hand. And the pinky is not instrumented, so that's why you get a period there. And the vertical bar characters indicate that my fingers are parallel and outstretched. The last 2 characters indicate the overall orientation of the hand with respect to the screens in the room. So the orientation changes as the hand flops around, but the finger pose does not. If my thumb becomes extended, then you see the vertical bar turns to a hyphen. If my index finger goes toward the plane, then that becomes an X. So from a kind of hardcore CS perspective, it really amuses us that all of the fantastic dexterity and expressiveness of the hand gets boiled down to 8 ASCII characters, which you then do a string match on to figure out what the pose is.
Wow.
That's all, again, part of a somewhat isolated input pipeline. That input pipeline could also be connected to a PrimeSense sensor or a Kinect, or to a mouse or an iOS or Android device, and we'll show you all of that stuff.
Okay.
But what's interesting is that when you write a program in G-Speak, you automatically get hooked up to as many different varieties of input as are physically connected at any one time.
Do you have any competitors who are doing similar thing or thinking about similar things, or are you completely out there on your own right now?
I think it's fair to say that we're alone in considering this kind of gestalt problem of bringing together all devices, bringing together a kind of collaborative multi-user system, and one that can address an arbitrary number of heterogeneous screens. And from our point of view, you have to get your arms around all of that at the same time in order to take the kind of step that we're talking about.
Are you mixing in voice control into the system so that you can talk to it?
Yeah.
I'm starting to see this stuff like there's a startup called an app on the iPad called MindMeld that was just shown off at TechCrunch, where you just put it on the desk and it listens to you as you have a meeting, and it brings information up about what you're talking about. And certainly we've seen Siri, and Google has voice control.
Yeah, we gave a talk at Disrupt just the other week, and we were backstage when they were showing MindMeld. That's really, really cool stuff. We have integrated speech recognition for a bunch of different customer projects. There's kind of 2 interesting ways to do that. One is to try to do the recognition so that you're talking to the machine and can issue commands. The other thing that's interesting is to use your voice for the benefit of other humans. So we could literally leave a voice annotation tagged to a particular piece of geometry in the room or in the media that we're browsing, so that someone could come along later. It doesn't mean anything to the machine, but that may not matter. It might be more important that you come along later and see what I had to say about that little bit of landscape, let's say. Let's keep zooming through these demos here. So this is, again, video, as we saw before, and we've got very kind of gross level remote control here, just with the hand. So play forward, pause, or stop in the name of love, and play backwards. And of course the system doesn't care whether you're right-handed or left-handed or ambidextrous. It invites all of that. Then there's using, again, one finger to point, as we saw before. In this application, controls time. So you're indexing into the timeline that's at the bottom there, and you're doing it either discontinuously or you're doing it continuously in order to scrub through the video, which has the really fabulous effect of surfacing temporal or chronological artifacts that are hard to see any other way. So if you point with 2 fingers, the cursor changes and you're grabbing space instead of time. So you can grab with one hand, grab with 2 hands, and now we have a way to move around the image and in fact to stretch it, to zoom, just by grabbing and kind of pulling like that.
That's awesome.
Yeah, it feels good. Now when we zoom along, we see that strange distant artifact, which in real time seems to be stationary, is in fact moving just very, very slowly. And you can put your wetware and your pattern matching abilities to work trying to figure out what that thing might be.
Yep.
High-res footage is, of course, equally accessible. We know that sensor and display resolutions in general never match, and that's fine because what's important is to provide people with a facility, again, for zooming, for navigating scale, the kind of Charles and Ray Eames powers of 10 idea that it's important to be able to get from the macro to the micro in a very smooth and cognitively meaningful way. So here, when we zoom in, we actually get more and more resolution.
Can you have multiple people using this system at one time?
Oh, yes.
And there's more gloves.
There's more gloves. So,
and does it know that it's you controlling? So
yes,
it's doing face detection, or how does it know?
In this case, the gloves are unique, so it knows that this is this set of gloves that I've been sweating into for the last 2 years or whatever, and a different set is a different pair of gloves. Yeah, we may want to switch here. But
no, I've got to hold the camera.
Okay. It's almost a kind of inevitable corollary of this style of work that when you say, all right, we're going to step back from all these screens, because back here is the one place where we can point to anything, where you can grab something off the front, throw it to a laptop or a tablet or something like that, or drag from the front screen down to this screen. Once we've stepped back, there's now physical and social space for other people to work. So we're finally kind of smashing open that horrible old narrowing limitation that says, well, one person gets one screen and one mouse connected to one machine. It's a little bit solipsistic, and I think there's a whole new world of use styles that emerge when you give people the possibility of really collaborating directly.
Okay.
And building systems that expect that and encourage it. So, back we go. Oh, hey, Cindy.
Hi.
How you doing?
Good. How are you?
I was just moving these letters around.
I'm Cindy Goodrich. I'm the head of marketing for Oblong.
Very cool.
Yeah. Okay, so.
I sure could use some help.
I was going to say, well, I can use so. Okay.
Cindy's.
So here's my.
A bunch of commands. I'm over here with the W and the H. There she is with her cursor. While she's doing that, I can make different kinds of mess with things. She's cleaning up. She goes home, grabbing the carrot. So we can accommodate sort of arbitrary numbers of participants. And we design our systems and our UIs to place all of those problems, to place all of that design in the UI realm and in the social realm.
And here you can see the what do you call the API that's coming in, the little 8-character set?
We call those gripe strings.
Gripe strings.
Gestural reduced instruction pose system.
Okay. And so an extra one showed up because she popped in here, right?
That's right.
Cool. And if I showed up with a pair of gloves, it would add a third one in. And you can, there's no limit on the numbers of people that can come into the
system? At a certain point,
How many people can you fit into a virtual?
Clowns in a VW bus, right?
Well, we fit 18 people into a Mini at Rackspace. So.
All right, well, so there's your answer. Now, it doesn't leave you a whole lot of room for this. So yeah, I mean, the kind of multi-user thing is really, really a key piece of our story.
All right.
Let's go back to the idea of navigation. We looked before at navigation through a really high-res bit of 2D imagery. We can do the same thing in real 3D. It's the same hand pose, and so that moving left and right and up and down gives us access to X and Y. Moving in and out gives us access to real Z, kind of 3-space Z, which is nice. And then there's the rotational degrees of freedom. So just by tipping your hand at the wrist, up and down, left and right, you can pan and tilt. It turns out that that your brain and your body know how to conspire to fly. Like all the dreaming you've done since you were a tiny child that involves flying has not gone to waste. Here, we can exercise all those degrees of freedom to support really sophisticated camera control.
Yeah.
So we're spiraling around, zooming in on that thing, keeping it framed. We can crane up, tilt down. And to be able to fly is not just a capricious matter. It's actually really important because we're joining to the idea of visualization, which is a kind of well-researched and well-developed field. The idea that if we can bring navigation to it, if we can join those two together, you're now serving both giant chunks of brain. And again, you make available new kinds of insights, new kinds of pattern matching for the smartest computer in the room.
Now, if I had an oil company like a Chevron or something, I imagine this kind of system would be really useful for flying through a 3D map of an oil field or trying to find out, where should we drill? Let's look at this piece.
Exactly. And we built exactly that kind of system in collaboration with Aramco.
Okay.
So the world is filled with all kinds of problems that are best expressed in 3D or best expressed spatially, sometimes 2D, sometimes 3D, you need a system that lets you get around really, really fluidly.
What do you have to do to the data to make it really useful in such a system? You know, what kinds of things really work well in this kind of environment?
Well, again, we've designed GSpeak to be for general purpose computing. So obviously, anytime you can take a bunch of abstract data and spatialize it. So let's take 20 years of mutual fund performance. And rather than sticking it in a spreadsheet or in a bar chart, let's actually array it in 3-space and then fly around it. Let's look at it from this point of view, and the patterns start emerging. You can see that stuff. You can feel it viscerally. So anytime you've got the opportunity to spatialize data, you should do so.
Okay.
Annotation is a simple but really important idea. As far as we're concerned, every app should allow you, at the very least, to make some sloppy Madden-style annotations. You should be able to draw an arrow or circle something that's important, or draw an X through something that you want to get rid of. Here, of course, we're literally drawing in the plane of the screen there, but we can also rotate the underlying coordinate system to provide a new kind of access to 3D. Rotate that once again, and
wow.
There we've just built that thing, whatever it is, in 3D. We can save that and try the next more interesting thing, which is to use one hand to leave marks in the space, and the other hand to rotate the underlying space. And that's the kind of, synthetic 3D feat that is probably not worth trying with any other kind of interface.
Could you do the same kind of things and draw on the screen? Because our finger is a little bit more accurate when touching a surface than trying to point.
Yeah, and that's why I described that as
or maybe on a surface
sloppy
like
annotation. So when you're doing fine motor control tasks, that's when you actually want some contact. You want that frictional feedback or the pressure feedback between your hand and the surface, or with a stylus as intermediate. But for quick annotation, you should just always be able to reach out and swipe through something. Let's go over here for a second. So this is the kind of application that we very, very originally, working with clients like Boeing, helped to build. This one is actually just a demo that we built ourselves to show what might be possible. But the notion of being able to navigate around such an important space, the Earth, very fluidly, very quickly, very deftly, is really important. So that's space control, and then temporal control happens like that, and we've just turned on playback of 6 weeks of FAA data. So these are all of the planes that were in the air during the last few hours of 2005. It's New Year's Eve. And right here we're seeing something that we know intellectually, but now we're experiencing it viscerally. Those are red-eye flights leaving the West Coast. They've just gotten to the East Coast. It's the morning of the first day of the new year. You see the time zones coming online, people going to the airport and getting on planes. So again, the idea that we combine visualization with really powerful navigation means that you've got more and new and better ways to understand what's going on. So that's what it feels like to be at nearly ground level at Dallas Fort Worth. And we can ask questions in the same way. So we can fly over here, more or less where we're standing currently, and scrape those airport names off the surface of the globe and say we're only interested in flights that terminate in SFO or Oakland. And now we've filtered the data.
Wow.
So, this is, of course, an intensely 3D problem, the complexity of the airspace above the planet, and it probably is going to benefit from a real 3D treatment.
Yep.
Let me show you one more thing before we trot next door to the next room. This is a system that we built to exercise some of the really fine-grained media handling capabilities that it was becoming clear needed to be a core part of our framework from the very earliest days in 2005, 2006. And we imported a bunch of movies into here, frame for frame. There's 18 or 24 or so. And each of them can be played and paused and rewound, as we saw before. And then there's also finer-grained controls, so we can single frame advance, go backwards or forwards, like this. And then just by adjusting the height of the hand in the application, you add progressive multipliers to that until at the very top you're accessing the entire film.
Wow.
But we decided to go one step further then, and with your hand held like this, you can isolate rotoscoped elements from the different films And you can grab those elements, bring them back to life, and then pull them down to the composing table. So we'll take that guy from Branded to Kill, and maybe come over here to Playtime. And we've got a lot of different layers here, but we'll give the Branded to Kill guy a friend. In fact, I'll give him a few friends. And just to keep the peace, it's probably advisable to grab Cowboy, partial to Woody Strode myself. He's wandering around there now as well. And probably a police escort is a nice idea. So here we are from vanishing point. We'll take this big dust cloud and put it down on the table there. So, you know, at the same time, this is kind of a glimpse at what the future of media production might be. This is obviously a simplified version of something that you want to use.
Final Cut 15.
Exactly. Well, you get to cut 15 a lot faster, I think, this way.
Yep. No, that's really cool. Thank you so much.
Sure.
We'll start part 2 shortly.
Let's begin.